Hello everyone, I'm going to do problem 37 on the chapter 10 homework. A block of mass m1 equals 2.00 kilograms and a block of mass 2 equals 6 kilograms are connected by a massive string over a pulley in the shape of a solid disc having a radius of 0.25 meters and a mass of 10 kilograms. These blocks are allowed to move on a fixed wedge of angle 30 degrees as shown below. The coefficients of kinetic friction is 0.36 for both blocks. Draw free body diagrams of both blocks and the pulley. Determine A, the acceleration of the two blocks, and B, the tension. So I've drawn the diagram for it. I'll fill in the forces later, and I've underlined any necessary information. So those are the forces acting upon the first block. The ones labeled in red aren't really gonna matter too much, and there's TL for the tension of the string on the left side. And then there's the pulleys forces acting on it. There's again tension on the left and tension on the right, and those are different tensions. And finally, the M2 block also has its own forces. So first we're going to find a moment of inertia for the pulley, the disc. So it's mass times radius squared times 1/2. Just plug in the values and you get 0.3125 kilograms. And we're going to put that up there for now. Other formulas that we're going to need is force equals mass times acceleration. Acceleration equals radius alpha, tau equals moment of inertia alpha, and tau also equals radius times cross multiplied by force. And that's the diagram we'll get working with. So force of m1 equals mass times acceleration, which is equal to the tension going leftwards minus the frictional force. For force of the second object is also mass times acceleration, and it's the mg sine 30 since going down minus the frictional force and minus the tension. And tau is in moment of inertia times alpha, which is same as r times the tension in the right minus the tension in the left. So solving for tension on both, tension in the right is the second mass times gravity sine 30 minus mass times gravity times coefficient of friction minus the mass times acceleration. And then tension in the left is mass times acceleration minus mass times gravity times coefficient of kinetic friction. Tau is now we're just plugging TR and TL in, so it's R times all of that business. And these are just again all the things we're going to plug in. And so you just plug all of those in, and then you solve for alpha and you get 1.323 radians per second. And simply you just multiply that by the radius 0.25 and you get the acceleration 0.309 meters per second squared. And for the second part, you want to get TL and TR. And since we already solved for that beforehand, we're going to just plug in values now that we know the acceleration. So yeah, you just plug them in and then you get TL equaling 7.67 newtons and TR equals 9.21 newtons. Thank you all for watching.